Good evening. Good evening. Uh, Please tell your friend to join. Okay. So today, first I discuss plots of residual in time sequence. Subrojit, good evening. This is the continuation of previous class. That is the adequacy of the model. So the first topic going to discuss, that is plots of residuals in time sequence. So if the time sequence is which in which if the time sequence in which the data were collected is known, then the residuals can be plotted against the time order, and we proceed as follows. Consider the residuals on y-axis and time order on x-axis, and this is the same way we have plotted residual against, is the same way as we plot the residual against y I hat predicted value, and in place of and in place of yi hat, that is predicted value, just to use time order. And the interpretation is if all residual are considered, in a horizontal band and the residuals fluctuates more or less in a random fashion within this band, then it is desirable and indicate that there are no obvious model defects. Model deflects, not defects, deflects. Okay. So, secondly, outward opening, just like a residual versus predicted plot, then here also the interpretation is same. So outward opening funnel shape or inward opening funnel shape, then it indicates that the variance is not constant but changing with time. And lastly, that is the point number 3, double bow pattern or nonlinear pattern, when it indicates that the assumption indicate that the assumed relationship is nonlinear. In such a case, the linear or quadratic terms in time should be added to the model. I mean to say, if you consider time as the explanatory variable, then if this thing is happened, that is double bow pattern, in that situation you should add time as a linear or quadratic terms. That means t or t square, if t represent the time. Okay, so the time sequence plot of residuals may indicate that the error at time period are correlated with those at other time periods the correlation between model errors at different time periods is called autocorrelation. So the correlation between model errors at different time periods is called autocorrelation. Okay, we are going to discuss later in detail. Okay, if we have a plot like as like following. See, so this type of plot indicates, then it indicates the presence of autocorrelation. So here in x-axis we in x-axis we plot time. Okay, then if you look at this, if plot look like this, in that situation it indicates there is a positive autocorrelation. And if plot look like this indicates negative autocorrelation. Okay, so this is a, if plot look like this is a presence of positive autocorrelation, and this is a presence of negative autocorrelation. Okay, so if you, so whether autocorrelation presence and or not, you can visualize this thing via this plot. Just plot residual versus time versus residual, and if your plot look like this, any of these two type, then you can say that there is the autocorrelation present, and depending on the graph, you can say whether it is positive and negative. Okay, so you can, oh, Shasti, good evening, you are late. Okay, 15 minutes left. So okay, no problem, Shastik, just I started. So next, we consider partial regression and partial residual plot. So Shubhajit, can you tell me, do you need to take, can I go to the next slide or not? Shubhajit, I am asking you. Shubhajit Shastik, tell me, can I go to the next slide or not? I forgot to mention this thing. Please tell me, can I go to the next part, Shubhajit? Shubhajit or Shastik, tell me. Okay, Shastik. Okay, Shubhajit, thank you. So next part is partial regression and partial residual plots. Okay, we already discussed why this thing is needed in our previous class. So today I am going to more detail about this. So partial regression plot this is also called as added variable plot or adjusted variable plot. Is a, so partial regression plot is a variation of the plot of residual versus the predictor. It helps better to study the marginal relationship of explanatory variable of an explanatory variable given the other variable that are in the model. Okay, so a limitation of the plot of residuals versus an explanatory variable is that it may not completely show the show the correct or complete marginal effect of an explanatory variable given the other explanatory variables in the model. The partial regression plot is helpful in evaluating whether the relationship between study and explanatory variables is correctly specified. They provide the information about the marginal usefulness of a variable that is not currently in the model. So usefulness of a variable that is not correctly in the model. So in the partial regression plot, First we regress y on all the explanatory variable except the jth explanatory variable xj and obtained residuals given xj and this is depending on, I already used this notation x within bracket first bracket j. This means you exclude jth explanatory variable and using remaining explanatory variable, that means x1 x2 xj minus 1 to xj plus 1 to xn xk. Suppose you use k explanatory variable, using this k minus 1 explanatory variable, using least square technique, you can find regression equation, and using this regression equation you can get this residuals. Okay, so you know this thing. So this residual, basically I mean to say, this is a observations minus, suppose I denote this coefficient by beta naught star beta 1 star x1 beta j minus 1 star xj minus 1 beta j plus 1 star xj plus 1 beta k star xk. Okay, so basically this is the expression of this residual. So in that way you get how many how many residuals partial regression plot? You get k partial regression plot, because in every time, so you do first thing, this is the residual obtaining the when you omit first explanatory variable, then second explanatory variable, and so on, and every time you get a you draw a partial regression plot, and in that way you get k partial regression plot. Okay, so first step is regress y on all explanatory variable except the jth explanatory variable xj and obtain residuals exj given x j within bracket first bracket j, say. So in that way you get k minus k the partial regression plot, So then you plot both this residual against xj given xj. I want to one more point. Actually, I forgot to mention one this thing. First, you regress y on all explanatory variable except the jth explanatory variable xj and obtain residual this. Okay, this is the first. And secondly, regress. This is the second point. I omit this point. Forgot to mention this point. Please insert this point. So regress xj on all other explanatory variables and obtained the residual okay. So you, in a way, you get this and plot these two. Okay, so this plot provides these plots provide the information about the nature of the marginal relationship for jth explanatory variable jth explanatory variable xj under consideration. Okay, so these plots provide the information about the nature of marginal relationship for jth explanatory variable xj under consideration. So if xj enter into the model linearly, then the partial regression plot should show a linear relationship that is the partial residuals will fall along a straight line with non-zero slope. Why? How? Suppose this is our model, okay? Y equal to x beta plus epsilon. And I beta curl x. Okay, so I write x as x1. This is the first column, first row of x matrix. Sorry, just use this. x1, x2, xj minus 1, xj, xj plus 1, xn. So and it is better to write in that way. It's better, not column, not row, column. Okay, so that is x1, x2, xj minus 1, xj, xj plus 1, xk. Suppose I use k explanatory variables, and this is the parameter beta 1, beta 2, beta k, epsilon. So we can break, I combine, I write this as, okay, so I also write I not equal to j xi beta I plus xj beta j plus epsilon, and this part is nothing but a x within bracket j, deleting the or omitting the jth column, beta j plus xj beta j plus epsilon. So this model can be written as this. Now we know E equal to I minus H. H is a hat matrix, so we already defined in our previous class. So H is nothing but a x prime x inverse x prime, and similarly we define Hj when we fit the regression equation using only x1, x2, xj minus 1, x1, x2, xj minus 1, xj plus 1, xk. Just eliminating this thing. Just do it. Okay. So just eliminating the jth explanatory variable, then we can get x h within bracket j is nothing but a, you can check this thing, we get this. Okay, so this is a hat matrix based on h, sorry, based on x1, x2, xj minus 1, xj plus 1, xk, which we collectively denote x within bracket j. Now, if I pre-multiply this y equal to x plus beta epsilon by I minus hj both side, we get, and instead of this part I use this part. Okay, so then this is equal to x within bracket j beta j plus x j beta j plus epsilon. Okay, now we know for full model we know I minus h, this is a projection matrix on the error space. So if you multiply by x, post multiply by x, this gives 0. We know this thing. Okay, or you can check it easily. Just x minus h prime means hx means x prime x inverse x prime x, so this gives 0. So we know this fact. So here also so this term is vanished, because in that situation when you deleting xj, so this is, first I write all this thing, then I am telling you. So this portion is 0 using this fact, and then here beta j is scalar, so we can write this portion as, and I denote this part by epsilon star. So therefore this is the error term. So this error is nothing but a, when you use only when you omitting the jth explanatory variable. This is the residual part, when you residual part of the regression, when you omit jth explanatory variable. And yes, Vaibhav, good evening. So please follow our class. Okay, so this is a residual of regression when you omit jth explanatory variable, and this part is nothing but a residual of what? Residual of where the study variable is xj and explanatory variable is x1, x2, xj minus 1, xj plus 1, dot 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 xk. Okay, so this is this part is this. Okay, plus epsilon star, where epsilon star is so please tell me. Yes, Shubhrojit, Okay, sir, what will be the case for G inverse? Subhrajit, since here I consider regression model, so regression model is a full rank, X is a full column rank model because here all component is estimable. So G inverse concept is not needed here. Okay, are you agree? Because regression model is a full column rank model, so for regression model, uh, G inverse is not required because for all, here all components are estimable. When you consider ANOVA, in that case, we need G inverse because this is not a full rank model. Because in ANOVA, ANOVA means when we consider qualitative variables. In that situation we are interested only on contrast. Okay, in ANOVA we only or design of experiment we are interested in contrast. Okay, so in a contrast we are all it is not required to estimate all parameters. It is enough if your contrast is estimable. That is enough for testing. Okay, so for regression, this is the difference between regression and ANOVA. So in regression, since all parameters are estimable, so x prime x is invertible. Thank you, Subhrajit. So uh, so please tell me if you face any difficulties in this argument. So before going to the next part, can please tell me the calculation part if you face any problem. Subhrajit, please tell me. Vaibhav, if you follow our class, please tell me if you have, if you face any difficulty in the calculation part. I will explain you again. Otherwise, I go to the next portion of this calculation. Okay. So can I have a no problem if you tell me, sir, please repeat this again. I can repeat. So take your time. Please see all these calculation or argument parts, and then tell me if you are okay with that. Then I go to the next part of this portion. Okay, Shubhrajit, clear, sir. Okay, thank you. So, Shastik, are you happy with my argument or you need more explanation? Shastik, if you hear me, please tell me. Need more explanation? Shastik, are you hear me? So, okay, Shubhrajit, I think uh, so. This part, this part suggests. So this means this means this is the residual part of regression where y is study variable and x1 xj minus 1 xj plus 1 xk are explanatory variable, and this portion is the residual part of regression equation where xj is study variable, mind it, xj is study variable and x1 xj minus 1 xj plus 1 xk are explanatory variable. So please visualize these things first, these two parts separately. Then from here mathematically we see that there is a linear relationship between these two residuals. So this means, so from this mathematical argument, we can write, this suggests that a partial regression plot which is a plot between this means in residual there is a please think deeply what do you mean by E residual y given xj. So in residual, since you exclude, omit xj, jth explanatory variable, obviously in residual the there is the effect due to xj is present. Even here, if you look at this thing, xj given xj in residual, there are also a effect due to xj is present. So obviously there is a connection and it should be a linear. Okay. So this suggests the partial regression plot, which is the plot between y given xj and exj given x within bracket j, like this is like between y and x, should have a slope beta j. Thus, we can write, if xj enters the regression in linear fashion, the partial regression plot should shows linear relationship passing through origin, because if you look at this equation there is no intercept term, that means this passing through origin, that is the ideal scenario. So if xj enter in the regression in linear fashion, the partial regression plot, if it is linear fashion, that means please see carefully. Actually, I mean to say, suppose I consider two explanatory variables, beta 1 x1 plus beta 2 x2. So I do not know whether this x2 is linear with y or not. If it is linear, x2 is linear, then its partial plot should be a linear and it passing through origin. Otherwise, if it is not linear, then it should not linear passing through origin. Okay, so please, so this is the insight provided by this partial regression plot. Okay, so can I go to the next slide, Shubhrojit? Please tell me. Shubhrojit, Vaibhav Raj Jaswal, please tell me. Shashik, please tell me, can I go to the next part if things are finished? Please tell me. Shubhrojit, please tell me, can I go to the next? Okay, thank you. So this plot look like this. For example, like this. So if x2 enter in this model linearly, then this partial plot look like this. And if xj is if the partial regression plot shows a curvilinear band then the higher order terms in xj or a transformation may be helpful. So I mean to say, if your partial plot look like this, in that situation, you need higher order term, that is xj square, xj cube, etc., or you can use transformation. Okay. And if xj is a candidate variable which is considered for inclusion in the model, then a horizontal band on the regression plot indicates that there is no additional useful information in xj for predicting y. This indicates that beta j is nearly 0. That means if you get your partial plot look like this, then that means the corresponding explanatory variables is not useful. Okay. Consider an example. This is the model y beta naught beta 1 x1 beta 2 x2 plus epsilon. We want to know about the nature of marginal relationship for x1 and also want to know whether the relationship between y and x1 is correctly specified or not. So to obtain the partial regression plot, first we regress y on x2 and obtain the fitted values and residuals. That is yi hat x2. This is just based on x1 x2 only. So this is fit estimate of theta naught intercept term xi1 and corresponding residuals just yi minus yi hat x2 I from 1 to n. Suppose I used n observation. Now in step 2, regress x1 on x2 and find the residuals. That is, first I fit x1 based on x2, and that is x1 hat, where explanatory variables is x2. This is alpha naught hat alpha 1 hat xi2. Both cases I use least square technique. All the situation here only talking about least square technique. Okay. Okay, Subhrojit. Sir, in the case of curvilinear partial regression plot, the model may be, but how to determine? No, Subhrojit. Uh, from partial regression plot, Subhrojit, can you hear me? Okay, I am answering your queries. Okay, so partial regression plot just provide you whether xj is linear or not. If it is not linear, that means it doesn't imply it is just quadratic form. Okay, it may be quadratic, maybe cubic, I do not know. You need to find out. I I suggest some solution, that is either you can use transformation or you add quadratic, cubic. It is depend on the situation. Okay, I will discuss the procedure uh, how to add this, how to use this transformation. Okay, in the coming classes. So for time being, you can, it is enough for us. That is, from partial plot we can easily see that whether this explanatory variable is linearly related or not. That is, that much I can say, not further. I do not, partial plot suggest you some idea whether it is quadratic or cubic, etc. But uh, this is not exact xj square. Okay, so this you write this thing. Okay, so whatever you write, it is one of the suggestions. Okay, it is not, it may not be hold for all the cases. Understand, Subhrojit? Okay, so one more thing I can add it, uh, depending on your plot. Actually, this is a trial and error method, even up to our knowledge, which I taught just on the basis of our teaching, on the basis of our discussion up to that class. We can just trial and error and check whether it is true or false just using this residual plot. Suppose you add xj square, let me finish. Okay, the xj square, then you can treat xj square as xj star. Okay, and then again you can draw partial regression plot. If your plot suggests these things, then it is okay. Xj square, you can add xj square in the model because you get this residual, this plot. If it is not like that, in that case you can add xj cube, xj4, and every situation you can draw this residual, this partial residual plots. Okay, and till your residual, until your residuals look like that. So this process is going on. Okay, happy, Shubhrojit? Okay, so xi1 hat x2 equal to alpha naught hat plus alpha 1 hat xi2, and here ei x1 given x2 is xi1 minus xi1 hat x2 I from 1 to n. If, point number 1, if x1 enter into the model linearly, then plot will look like this. Plot will look like as this. Okay, and can I go to the next slide, Subhrojit? Please tell me. Subhrojit, please tell me, can I go to the next slide? Okay, thank you. And the slope of this line is at this point here. If x1 into model linearly, then plots will look like as this, and you add this thing. We already seen that the slope of this line is a regression coefficient if the regression coefficient of x1 in the multiple linear regression model. So why I already see this thing here, I have seen this thing. Just see the calculation part. Okay, so here we see that this is the regression coefficient. Beta j is regression coefficient of the original model, and here we see that for this regression line where we use y given xj as as study variable and exj given xj is a independent variable. Even that situation, beta j is also the slope in that situation. Okay, we already see this thing, we have already seen this thing. Okay, so that's why I write this thing. So the slope of this line is a regression coefficient of x1 in the multiple linear regression model. Okay, so if the partial regression plots shows a curvilinear band, then higher order term in xj or transformation of xj may be helpful. Okay. And note that if x1 is a candidate variable, which is considered for inclusion in the model, I think it is better to write in that part. Okay. If your partial residual plot look like, we already discussed this part. So in that situation, we can write if x1 is, say, candidate variable, which is considered for inclusion in the model, then a horizontal band on the regression plot indicates that there is no additional useful information for predicting y. That means you can eliminate x1 from this model. Okay, so we get three type of graph. If your graph look like this, you are happy with that situation. That means x1 enter in the model linearly. If your plot look like this, in that situation you need higher the term in xj, or you need a transformation. So you need to check one by one. Either you can x1 j square, xj square, xj cube, etc. And every time you plot uh, partial residual plots and look whether this portion is straight line going from origin or not. Or either you can use transformation like log transformation, or uh, root square transformation. There are so many transformation you can use one by one, and check every time your partial residual plot whether this is a straight line passing from origin or not. If it is passing from origin and it is straight line, then you can stop there and take this transformation or higher term in the model. Okay, and if your partial regression plot look like this, partial plot is look like this, in that situation you do not need to add this explanatory variable in this model because it is irrelevant. It does not give uh, informations, or it is not useful for the model. Okay, so some comments on partial regression plot. partial regression plot need to be used with caution, as they only suggest possible relationship between study and explanatory variables. The plot the plot may not give information about the proper form of the relationship of several variables that are already in the model are incorrectly specified. Some alternative form of relationship between study and explanatory variable should also be examined with several transformations. Residual plots for this model should also be examined to identify the best relationship or transformation. Point number 2, partial regression plot will not, in general, direct interaction effect among the regressors. Point number 3, partial regression plot are affected by the existence of exact relationship among explanatory variables. This is a problem of multicollinearity. We will discuss this later. Problem of multicollinearity, and the information about the relationship between study and explanatory variables may be incorrect. In such cases, it is better to construct a scatter plot of explanatory variable like x1 versus xj. If they are highly correlated, multicollinearity is introduced and properties of estimators like ordinary least squares or least squares of regression coefficients are disturbed. So this is the some points. So please tell me, have you any queries? So you ask me, sir, how do I test coefficient of multilinear regression models? I will discuss this in my previous class. Please go through. I think it is a day 3 regression analysis, day 3, day 2. Please follow this day 2, day 3 classes. I will discuss. I already discussed this thing. Okay, so I think it is in our playlist. Please follow this thing. Okay, thank you for your queries. So today I am just discussing about adequacy of the model. Okay, so please go through day 2 and day 3 classes. I have already discussed. Generally, for your queries, this is a very undergraduate level questions for asking. That is, we actually we use t-test for uh, student t-test for testing this thing. Okay, just go see these classes I already discussed. Thank you. So have you any queries, Subrojit? Uh, Moina Coil, you wrote, sir, today is my birthday. Okay, thank you. Moina, it is happy birthday. I wish you happy birthday. So, so actually in this class we discuss partial regression, partial residuals plot, and we discuss three type of curve. If this type is happen, we are fine with the present present position with x present position of the explanatory variable. That is, if you interested in checking the x2, whether x2 is linear or not, if it is regression residual plots look like, then you are happy with x2. If it is look like this, then you need higher order term of x2, that is x2 square, x2 cube, etc. And every time you draw partial residual plot, and if it is actually, Subrojit, we will discuss how to eliminate multicollinearity. Okay, I just read the we'll discuss in later multicollinearity. There is a this is a huge portions. We need a whole class for multicollinearity. Okay, so please wait. We'll definitely discuss. And every time we draw the one simple solution is, if Subrojit, I am telling you, if suppose no, not okay, just I am telling you one simple thing. Suppose if your two explanatory variable x1 x2 is related, what happened if you use x1 x2 both, then the beta, it affects on your beta 1 beta 2. Okay, so in that case the simple solution is either you use x1 or x2. Okay, no need, because already the information of, if you use x1, already the information of x2 is present in x1 also, because they are correlated. So we will discuss it later. Okay, and every time we draw, so if your partial residual plots look like, then uh, we need higher order term in xj, and or you need transformation, and every time we draw partial residual plots until your plot look like this. And if your plot look like corresponding x2 equal x2 to the power j, suppose x2 to the power j, in that situation you enter x2 to the power j in the model. And if your this partial residual plot look like this, then this x2 is, you can omit this x2 from this model, because it does not give information, significant information to the model. And these are the some points. Please note this point. Okay, so next we discuss statistical test. On residuals. So we may apply certain statistical tests to the residual to obtain quantitative measure of some of the model inadequacies. They are not widely used. In many applications, residual plots are more informative than the corresponding test. However, some residual plots do require some skill and experience to interpret. In such cases, the statistical test may provide useful. Actually, I want to say, in general, partial residual plots provides us about the residuals, whether uh, from the residual plot we can easily interpret whether it is the assumptions of the regression is satisfied or not, whether there is an outlier or not, etc. But sometimes residual plot do require some skill and experience to interpret. Actually, please note that sometime, I think it is better to write in that way. In many applications, residual plots are more informative than the corresponding test. However, some residual plots do require some skill and experience to interpret. In such cases, the statistical test may useful. We know the phrase statistic. We recall the phrase statistics here. We already defined phrase statistics. Or we already familiar with this notation. Okay. We already, this was your homework part. So the phrase statistics is a measure of how well a regression model will perform in predicting new data. So this is also a measure of model quality. A model with small value of praise is desirable. This can also be used for comparing regression model. Now, R square for prediction based on praise. The praise statistics can be used to compute an R square like statistics for prediction say R square prediction equal to 1 minus praise by SS due to total. Okay, so please tell me, can I go to the next slide? Can I go to the next slide? Subrojit, please tell me, can I go to the next slide? Okay, so the statistics give some inductions, give some indication, sorry, give some indication of the predictive capability of the regression model. For example, Suppose if your r square is equal to 0.89, then it indicates r square means here r square is a r square prediction, okay? Then it indicates that the model is expected to explain about 89% of the variability in predicting new observation. Now, detection and treatment of outlier. Outlier means this is the extreme observations. An outlier is an extreme observation. If the residuals is considerably large, that means residual that are considerably that are considerably large larger considerably larger in absolute value than the other others, say 3 or 4 times of standard deviation from the mean. Indicate indicate Actually, yes, Subhrajit, we will discuss. Actually, we will going to discuss depending on press residual. We will give a statistics based on t-test. Actually, using press residual, we will provide the statistics based on t-test. Okay. Of course, there is a threshold. Otherwise, it is not possible to say how small. You are right, okay, but thing is that if you look at the value of r square prediction, okay, Shubhrajit, are you hear me? The r square prediction, it should be lies between 0 to 1, okay. So if your press residual is larger, that means your r square prediction should be smaller. And if r square prediction tending to 0, that means your prediction is not good. Okay, just look at r square prediction. Okay, Shubhrajit, then you can understand. Okay, clear? Okay, so so 4 times of SD from the mean indicate potential outliers in Y space. This idea is derived from the 3 sigma or 4 sigma limits. Depending on their location, outliers can have moderate to sharp. Depending on their location, outlier can have moderate to severe effect on the regression model. Outlier may indicate a model failure for this point. Residual plot against yi hat and normal probability plot help in identifying outlier. Examination of scale residual for example studentized and art student residuals are more helpful as they have mean 0 and variance 1. Outlier outlier can also occurs in explanatory variable in X space. They can also affect the regression results. Sometimes Sometimes outliers are bad. Outlier are bad values occurring as a result of unusual but explainable events. For example, faulty measurement, incorrect recording of data, failure of measuring instrument, etc. Next point, bad values needed to be discarded but should have strong non-statistical evidence that the outlier is a bad value before it discard. Before it discarded. Discarding bad value discarding bad values is desirable because least squares pool because least squares pool the fitted equation toward the outlier. Sometimes outlier is an usual sometimes outlier is an unusual but preferably plausible observation if such observation are deleted then it may give a false impression of improvement in fit of the equation. Okay, so please write down these notes. Okay, these are very important when you decided whether this outlier you whether the outlier is discarded or not. You should keep this point in your mind. Okay, so next point, sure. So next point, you should consider this point. Sometime the outlier is an unusual but actually sometimes the outlier is suppose the outlier is more important than the rest of the data because it may control many key model property. And the effect of outliers on the regression the effect of outliers on the regression model may be checked by dropping this point and refitting the regression equation. And the last point is the value of t statistics, f statistics, r square, and residual mean square may be sensitive to outliers. So before going to discard these outliers, you should keep all this point. So that's why I'm writing this thing. So have you any queries? I want to end this stream for I end the stream today. So next day we'll discuss. I know I actually there are some guy I do not know who are you. Yes, this is 2021. I know, but I think this class for not for you. I think you can go other classes. There are so many people for 2021. You go to join their classes. Okay. So I do not want you in my class. Okay. I do not need you actually. There are so many people left, excluding you. Those those who needed these things. Okay. So please let this class immediately. You are very irrelevant elements. Thank you. So next day we will going to discuss. Uh, we will continue this topic next day. Okay. So we will discuss some test related to this. And then we going to the discuss the goodness of fit. Okay. So goodness of fit test. Okay. So if the time is permit, then we will discuss uh, another topic, that is how to uh, actually how to use these transformations. Okay, actually transformation of variable. So please tell me, have you any queries? So if please tell me if you have any questions. Otherwise, I end the stream. So please tell me. Shubhrojit, no queries, sir. Okay, thank you. So anybody, please let me know if you have any queries about this. Thank you. Okay, thank you. Okay, thank you.